doing so, I want to explain some basic concepts that I use while solving this. It's actually not that hard. You need to know what a box is and one property about it. So basically, if I write box of 2.718, it basically rounds it off to the greatest integer, but which is smaller than the number itself. So this gives you 2. So now, imagine I write something like 2.718 plus 3. This is an integer. So this gives you something like 5.718, and if you take the box of it, it just gives you 5. But the property I want to be using in this while solving this question is that the box of x plus n, where n is an integer, is just box of x plus n. It's actually very simple. Or another way you can understand this is distributing the box with the various elements, like box of x plus box of n. This can be written as box of n, but n is already an integer, so it doesn't make much of a difference. So taking the same example, I can write this as box of 2.718 plus 3, which also gives you the same answer, 2 plus 3, which is 5. So now let's solve the question. Here they're given box of y plus box y is equal to 2 cos x. So now let's just simplify this. As I told you, this is in the form of box of x plus n, because this always gives you a natural number. I mean integers. So I can write this as, I can like distribute the outer box into the individual elements of the box. So I can write this as box y plus box of box y. But this doesn't really make any difference because this is the same as box y. It's like taking 1 and adding a box over it. It doesn't make any difference. It's still gonna give you 1. But like if I take 0.1 and add a box over it, it gives me 0. And if I add another box over it, it's still gonna give me 0. So that's the same thing out here. So this is basically, you can combine these two. You have 2 box y is equal to 2 cos x. So the 2 cancel. So you basically have box y is equal to cos x. I'll just write this up over here. And I'll make some space for myself. The second part is y is equal to 1/3 of a big thing. So let me just simplify this again. Again, using the same property, I can distribute the outer box into the various elements, and the box of these two into its various elements. So you'll be left with something like box of sine x. This doesn't really look like a box. Plus box of sine x plus sine x. If you want to understand why this works, I can take an example. So let's just take a random value of sine x. Let's just take x is equal to pi by 4. Now what happens to this is you have 1/3 of 1 over root 2, and 1 over root 2 is approximately 0.7 or something. 0.7 plus box of 0.7 plus box 0.7. Essentially, this is what is given. So how would you simplify this? I can write this as 0.7 plus 0.7. What is box 0.7? This is just 0. And if it's 0, I think I don't have to write this plus 0. And now what is 0.7 again? It's just 0. And this again, box 0.7, it becomes 0. So can I say that this is the same as 0.7 box 0.7 plus box 0.7 plus box 0.7? And you'd say absolutely. So yeah, essentially that's what's happening. I've distributed the boxes to the various elements, and you can notice this, it's quite evident that I have 3 box sine x's. So I can just write it as 3 into box sine x. And 3 is an integer. Any integer can be taken out of the box. So this 3 and this 3 gets cancelled out. You just have sine x in a box. So you have y is equal to sine x. But we already know this from the previous expression. So now all we have to do is equate both of them and draw a graph, because sometimes graph is the easiest way of solving something. So what we have is box y is equal to cos x and y is equal to sine x. So how would you draw the graph of these? So let us start by drawing the first one. This is just your normal cos. I mean, I drew the sine by mistake. So yeah, this is basically just your cos graph. It goes like that. And your sine x graph, I mean box of sine x. So the second graph is gonna look something like this. So if you can notice this, here it's 1 and minus 1. In between it's 0 to 1, which, and all of them just get rounded off to 0. So it goes from 0, and at pi by 2 you have an open section where it becomes 1. Until here again you have it 0, And this, from here on, it's like minus 0.1. Minus 0.1 gets rounded off to the smallest integer that's less, the greatest integer, but which is smaller than the number itself. So like minus 0.1 would get rounded off to minus 1. So this is what would happen. You would have an open section. And the same thing over here, except over here, it becomes minus 1. And all of these areas just have it as 0. So if I were to draw the same graph overlapping with this is how it would look like. It would start over here, come till here, but then you have an open section. You don't really have a solution over here. And then over here, you basically have 0, no solution. And you have to come all the way till here. And when you're somewhere over here, this becomes 1 over here. And then, nope, you don't really have a solution. After that, there's this, you have 1 over here, but like, as long as you can see, there are no intersections, so there are no solutions. And that's the answer.